Hello everyone, welcome to my presentation. I am Sangeeta from Sri Venkateshwara College of Engineering, Bangalore, from the Department of Computer Science and Engineering. Today we are going to discuss about a concept stack from the data structures and its applications. Before going to the topic, first let's discuss about data structures. What is actually a data structures? A data structures is a way of storing and organizing a data in a computer. There are two types of data structures, linear data structures and non-linear data structures. What is linear data structures? Where the data are stored in a sequential order. The types of linear data structures is static and dynamic. In static, the example is array, and in dynamic, it is list, stack, and queue. The non-linear data structure is where the data are not stored in a sequential order. And the examples are graph and tree. Now let's see about stacks in data structures. The contents today we are going to discuss is introduction to stacks, operations of stacks. In operations, push operation, pop operation, overflow and underflow. And next, creation of stacks, display of stacks and applications of stacks. What is actually a stack is? A stack is a linear list of elements in which an element may be inserted or deleted at only one end. An end where element is inserted or deleted is called as the top of the stack. Stack is a data structure which works on the principle of last in, first out. That will be called as LIFO procedure. What actually the LIFO procedure is, the last element inserted will be the first element to be deleted. An example for stack where the elements are stored in a stack. The elements are 1, 2, 3, 4. So the default value of the top will be -1 and indexing starts from 0, 1, 2 to n values. Now here they are pushing a 5 element into the stack, or they can remove a 4 from the stack. Next is operations of stack. The major operations of stack are push operation, inserting an element into the stack. Pop operation, removing an element from the stack. Overflow, checking whether the stack is full or not. Underflow, checking whether the stack is empty or. First, push operation. Inserting an element into the stack is called push operation. First, check whether space is available in the stack. If available, then increment the value of top by 1 and then insert the element into the stack. When stack is completely full and we try to insert more element onto stack, then this condition is called overflow condition and no further element would be inserted now until any element is deleted. A small syntax for push operation, we are declaring a push function and then int of item if top is equal to size -1. Print stack is overflow. Return. Print enter an item. Scanf, we are taking an input from the user as an item. Before pushing any item into the stack, we need to check whether the stack is having available space or not. To check that, we are using a if statement. Top is equal to size -1. If the condition is true, then we cannot push any item into the stack. Else, we can take an input from the user as an item and then we can insert that item into the stack. Before adding that item into the stack, we need to increment the top by 1. Next is pop operation. Deleting an element from the stack is known as pop operation. Before performing pop operation, we need to check whether the element is present or not. If the element is not present in the stack, then the condition is known as underflow. Pop generates generates an error if applied to an empty stack. Thus, it's advisable to determine when a stack is empty by using the count property before popping the stack. A syntax for pop operation: while pop, we are declaring a pop function and then we are checking whether the stack is empty or not. If the stack is empty, then the default value of the top will be -1. So we are using a if statement. If top is equal to -1, then we need to print that stack is underflow. That means the stack is empty. Otherwise, print deleted item is equal to %d of s of top -1. If the stack is not empty and the elements are present in that, then we can delete that items. So to delete that, we need to delete the item first and then we need to decrement a top by 1. Next, overflow. In order to perform a push operator, we need to check whether the stack is completely filled with elements or not. If top is equal to size -1, print stack is overflow. When we use this overflow is full function is when we need to check that the stack is completely filled or not. We'll check this condition when we need to add the item to the stack. Underflow is empty. Before we delete an item from the stack, we must first check whether there are any item in the stack. If top is equal to -1, print stack underflow return. That means this condition we will check when we need to delete an item from the stack. To delete an item from the stack, we must know that some of the items should be present in the stack. So we know that the default value of the top will be -1. If the top value is -1, then we know that the stack is empty. So it should not be -1. If it is -1, then the stack is empty. So to check whether the stack is empty or not, we use underflow condition. Creation of stack. Before performing push pop operation, we need to create a stack. To create a stack, we use create function. Create function can be implemented as one-dimensional /define size 5 int s of size int top is equal to -1. Before giving the size to the array, we are defining the maximum size of an array must be 5 or less than 5. And we are declaring int s of size as an array where it is a stack. Int top is equal to -1. The default value of the top will be -1. We are declaring top is equal to -1. S of size is an array to hold the elements of the stacks. Display of stack. After performing push and pop operation, we need to display that. So we are using display function. Displaying the contents of the stack using display function. Void display. We are declaring a function as display. Int I. We are declaring a variable as I to perform for loop. And we are checking whether the stack is empty or not. If the stack is empty, there is nothing to display. So we are checking a condition whether the stack is empty or not. If it is not empty, printf contents of the stacks are for I is equal to top, I is greater than or equal to 0, I minus minus. Printf %d of s of I. If the stack is not empty, then we need to display all the items in the stack by using for. Applications of stacks. Where all the stacks are used in function call. Whenever we need to call another function in a function, we need stacks in it. Used in conversion of expressions, that is arithmetic expressions. Evaluation of expression. An arithmetic expression represented in the form of either postfix or prefix. Used in recursion. Used in polished notations. What is actually polished notations? Where the arithmetic expression is of three types: infix expression, postfix expression, and prefix expression. In all these expressions, we need that way the computer cannot understand the infix expression. It converts the infix expression into postfix or prefix expressions, and then it gives us the outputs. So to convert the infix expression into postfix or prefix and to store them, we need stacks. Thank you.